Okay, we're going to take another look at solving this system of equations by graphing. So again, finding where the two lines intersect at one point, which would be your solution. So our essential question is, how can we solve a system of linear equations? So let's do the first one together again. You have two equations, y equals 2x plus 5. And then we have y equals negative 4x minus 1. So I'm going to graph my first one, y equals 2x plus 5. 5 is my y-intercept. 2 is my slope. And remember, that's 2 over 1. So I'm going to graph this one first. Up 5 on the y-axis. My slope is rise 2, run 1. Remember, you want to go as far as you can on the graph. Once you have all your points, take your straight edge or your ruler and draw a line. It is super important that you're precise when you're doing this and that you put all those points on there so that you can guide your ruler, because even if you only put a few points and your ruler slips, then you're probably going to get the wrong solution. Okay, next one, y equals negative 4x minus 1. So negative 1 is my y-intercept. Negative 4 is my slope, so that's really negative 4 over 1. So I'm going to plot my y-intercept first, negative 1. My slope is down 4 over 1 to the right. Down 4 over 1. Then I'll go the other direction. Up 4, backwards 1. Up 4, backwards 1. Take my straight edge, draw your line for your second equation. And they should cross at one point. If they don't, you probably made an error. So here, my two lines cross at that point. So that is my solution. And when I list that ordered pair, that's over negative 1, up 3. And so that is my solution. Okay, now to check your solution in each equation, you're going to take each equation, plug in negative 1 for x and 3 for y. So my first equation, y equals 2x plus 5. Where I see an x, I'm going to replace it with negative 1. Where I see a y, I'm going to replace it with a 3. So I have 3 equals 2 times negative 1 plus 5. And then I'm trying to see, does this right-hand side equal the same thing as what's on the left, a 3? 2 times negative 1 is negative 2. Bring down plus 5. Negative 2 plus 5 is 3. And on the left, I also have a 3. So it worked for the first equation, meaning I graphed that line right. And now I'm going to try the next equation. Y equals negative 4x minus 1. So where I see an x, I'm putting negative 1. Where I see a y, I put a 3. So I have 3 equals negative 4 times negative 1 minus 1. So now negative 4 times negative 1 is positive 4. Bring down minus 1. 4 minus 1 is 3. And 3 equals, on the other side, I also have a 3. So the solution also worked for the other equation, meaning that I graphed it correctly and found the correct solution. Okay, example 2. Why don't you go ahead and try this one on your own? Just make sure that you notice for the first equation, y equals 1x minus 1, the slope is 1. And the second equation, y equals negative x plus 3, the slope is negative 1. So go ahead, push pause, graph the lines, find the solution, list the solution, and then push play. Okay, so your two lines should look like this, and your solution should be right at over 2, up 1, 2 comma 1. If you don't have that, you probably graphed your lines wrong, so pause your video and try to fix your lines. The next step that you need to do then is plug in this solution into your equation. So where you see an x, you're going to put a 2. Where you see a y, you're going to put a 1. So do that for each equation. Push pause. And then you can push play to make sure that you're checking the solution was accurate. Okay, when you check your solution of 2, 1, it works in the first equation. Okay, when you plug in a 2 for x and a 1 for y, you end up with 1s on both sides. And then for the next equation, when you plug in a 2, it also works. Just make sure that you have -1 times 2 is -2, plus 3 is +1. And that's also what you have on the left-hand side. Okay, now flip to the back. So now we're doing something without the graph. So the question says, check to see if the ordered pair is a solution to the linear system. So this would be like, if you graph these two lines, is this the point where they cross right here? And we're going to check it without a graph. So we're going to say anytime we see a x, I'm going to replace it with -3. And anytime you see a y, you're going to replace it with 5. And so we're going to check both equations and plug in -3 for x and 5 for y. So I'm going to write my first equation. Y equals -4x minus 7. And then I'm going to replace y with 5 and x with -3. So I have 5 equals -4 times -3 minus 7. And then I'm going to check and see. I have a 5 on the left, so if this is accurate, I'll also get a 5 on the right. -4 times -3 is +12. Bring down -7. 12 minus 7 is 5, which I have on the other side. Then I need to take my second equation, x plus y equals 2. And I'm going to replace x with -3 and y with 5. So I have -3 plus 5 is supposed to equal 2. -3 plus 5 is 2. And on the right, I also have a 2, so that is correct. So then we go down and answer. Is -3, 5 a solution to the linear system? Yes, it is, because when we evaluated it into both equations, it proved to be true for both equations. Okay, next one, we're going to work through these together because each example is a little bit different. So I have two equations, x minus y equals 5 and -3x plus y equals -1. So in this instance, where I see an x, I'm going to replace it with 4. And where I see a y, I'm going to replace it with -1. So my first equation, I'm going to rewrite that. I have x minus y equals 5. So I'm going to plug in a 4 for this x, a -1 for the y, and I'm going to write the rest of the problem. Now, I also have to bring down the subtraction sign because it said minus whatever y was, and y was -1. So minus -1 equals 5. Now I have to do 4 minus a -1. If you're taking away negatives, that's really adding. 4 plus 1 is 5, and on the right, I also have a 5. So it worked for that equation. Second equation, we have -3x plus y equals -1. So I'm going to replace x with 4 and y with -1. And write in the rest of the problem. So -3 times 4 plus -1, does that equal -1? So let's evaluate this. -3 times 4 is -12 plus -1. Does that equal -1? Well, -12 plus -1 is -13, which does not equal -1. These two numbers are not the same on both sides in this equation. So because it didn't work in this equation, the ordered pair for -1, it is not a solution. It has to work in both equations. So it does not work there. And last one. So I have two equations. Where I see an x, I'm going to put a 1. Where I see a y, I'm also going to put a 1. So my first equation, I have 1/2 x plus y equals -6. Replace x with a 1, y with a 1. So 1/2 times 1 plus 1, does that equal -6? Well, half of 1 is a half, plus, bring down the 1, equals -6. A half plus 1 is 1.5. Does that equal -6? No, it doesn't. These two numbers are not the same. 1/2 only equals 1. 1.5 only equals 1.5. So I'd have to have them on the same on both sides, or -6 and -6. So because it didn't work in the first equation, I don't even have to check the second equation with the ordered pair 1, 1. If it didn't work in the first, it's automatically already not a solution. Okay, you can bring your note sheet to the guest teacher, have them take a look at your notes, put them in the binder, and move on to the next step.